All right. So if you guys grab your notebooks if you haven't already. Okay, we have just a little bit of notes. And then also, just while I'm thinking about it, this chapter 2, everyone, is pretty short. So assuming we're in school all 5 days this week and we don't get, I don't think there's supposed to be any other weather besides just what we had today. So anyway, I assume that we are going to finish the chapter this week. But so that means I have your next test Tuesday next week. So Tuesday, the 15th. Remember that next week is our last week before break.
What?
Yeah, so we have all of this week and then all of next week, and then you have winter break.
How long do we get it for?
How long is winter break? It's a whole week. And then you only have to make it till April, and then you get a whole nother week for spring break. That's it. And then you just gotta make it to June. All right, anywho. So we are going to talk about starting chapter 2 today. So this is, ow, I just stuck my toe. Graphing integers on a number line. So this is 2-1. Graphing integers on a number line. So your first question might be, well, what in the world is an integer? That's a great question. Does anybody know before I tell you? Go ahead. Give me some guesses. What do you guys think integers are? You're half right. Say it again.
Odd numbers?
They can be odd, but they don't have to be.
They have to be whole numbers.
Whole numbers, but there's another piece to it. If it was just a whole number, I'd just call it a whole number, right? So why am I calling it an integer? That's the key. It's positive and negative whole numbers. Whole numbers are just positive. They're the 0, 1, 2, 3, 4, 5, and so on forever. But once you start including the negatives of all those, we call those integers. Notice there's still no decimals, there's no fractions. That's something else called a rational number, which we will talk about later. So an integer, these are just positive or negative whole numbers. And that's all it is. I can't tell you how many kids I could go into an algebra 2, algebra 3 class and ask them what an integer is. Everyone's heard it 1,000 times, but very few people will be able to give me an accurate definition. Okay, positive or negative whole numbers. So we'll just rattle off some examples. You could have negative 19. You could have 7. What about 0? Does 0 count or no?
I think it's just.
0 is not positive or negative,
About 4.
but 4 would work. The thing is that 0 is a whole number. So all the whole numbers are included as well as their negatives. It just so happens that 0 doesn't have a negative, but it still counts as an integer. Let's put it, you can have big numbers, 100. You could have negative 75. I mean, you could go on and on and on, literally forever. Oh, you know what? I'm gonna give you one more example that's like a trick question. I could give you something like this. Because what is 15 over 3 really? It's really just 5. If that had been any other number, like if it didn't come out nicely, then it would not count as an integer. But since 15 divided by 3 is just 5, that's really the number that you're seeing in that list. So if it was a not such a nice fraction, I couldn't have it in this list. But sometimes they're hidden like that. So don't automatically assume just because it's a fraction that it can't be an integer. There's a chance that it actually is. Okay. Okay. So let's talk about the number line now that we have talked about integers. I'm sure we're all familiar with the number line. Okay, it goes up forever in both directions. So usually somewhere around the middle, we pick that to be 0, sort of our center point. And then as you move to the right, all of these numbers are going to be positive. And what happens the further you get away from 0? What happens to my numbers? Are they getting bigger or smaller? They get bigger. So the further you go away from 0 in the right-hand direction, the bigger the numbers get. When you go on the left-hand side, though, when you are in negative land, everything changes. As you go further and further to the left, the numbers are getting smaller. This can be very confusing when I'm asking you to tell me which number is bigger and they're both negative. So let's try a little bit of that, okay? You guys are familiar with greater than, less than? Okay. Let's start off with an easy one. If I said, okay, compare for me 2 and 7. Which one of these two numbers is bigger? Of course, it's 7, of course. So I always learned it as it's, this is the mouth of the Pac-Man or the alligator, whatever you want, and it's always going to eat the bigger number. So our symbol should go that way. You would say this out loud as 2 is, huh?
So those are alligator symbols.
I learned it as a Pac-Man because I'm old.
They told us alligators.
Well, whatever you want to know it as. So you would read this out loud as 2 is less than 7. And it makes sense. I know I don't need to do this with these positive numbers, but it helps when we get to the negatives. If I looked at a number line and I put them both on a number line, remember, the further you go to the right, the bigger the number gets. So 7 has got to be bigger than 2. That can be helpful when we move into the negatives, because negatives can be weird. Because now let's just compare -2 with -7. Who's actually bigger here? It's -2. And the reason why it's bigger is because it's closer to 0, right? So I'd have -2 and then -7 way out here. So the further away it is from 0 on the left-hand side, these are smaller and smaller and smaller numbers going this way. So -2 has got to be my bigger number. So we would say -2 is greater than -7. By the way, if I ever asked you to graph -2 and -7 on a number line, you literally just put dots at their values. So there's a section on your homework where it'll give you some numbers and it'll say, hey, graph these. You just put dots at each of the numbers. Let's try one. I love these ones where one number is positive and one's negative. What if I had 3 and I compared it to -4? Who's bigger? 3. Any positive number is bigger than any negative. You don't even need to look at their values. It doesn't matter. Any positive is going to be bigger than any negative. So put a star somewhere. Any positive number is bigger than any negative. So that can make light work of some of the problems. Just knowing all your positives have got to be bigger. You don't even have to consider what the numbers that even are. The only time you kind of have to slow down and think about it is when they're both a negative or both positive. Okay, and then the last thing I want to talk about real quick. What is absolute value?
Negative is like in the 2 lines.
You're right. So its definition, Christian's 100% right. So if I have, they're the ones with the long bars around it. I'll show you an example in just a second. So what absolute value is, the reason why no matter what is inside those bars becomes positive. Does everybody know why we do that? Why does it just automatically become positive? What are we finding when we're talking about absolute value? Anybody know? We talk about it as the distance a number is away from 0. And that's why positive or negative, it doesn't matter. It becomes a, guys, are you listening? I feel like I'm having to talk over you. And that drives me batty. All right, so distance. If I ask you how far away from the school you live, nobody's going to respond with a negative number.
45 minutes.
You might respond with a time, but usually maybe you say, oh, I live a mile, 5 miles, 10 miles, whatever it is, but it doesn't matter what direction we're in. We would all give a positive number, wouldn't we? If I said, what's the distance you live from the school? You're going to say 5 miles, 2 miles, whatever it may be. No one is going to respond, I live -3 miles from the school, right? Because we don't talk about distance like that. Distance is always a positive value. And since absolute value is just a number's distance away from 0, that's why it's always positive. Okay, so absolute value is a number's distance from 0. And that's why it is always positive. So I'll say which is always positive. No matter what you plug in, whether you're taking the absolute value of a positive number or a negative number, what comes out is always going to be positive. So to draw absolute value, the symbol, we use those long bars like that. That's what we're talking about. So I'm just going to draw a number line real quick. So basically what I'm asking you in this question, is everybody with me? If I'm looking at the number 3 on a number line, how far away is it from 0? 1, 2, 3 units. So my answer would just be 3. Notice this is a common mistake. Sometimes kids will automatically just change the sign. They'll say that the absolute value of +3 is -3. No, it doesn't work like that. The answer is always positive, whether that's a positive number or a negative.
Well, those are easy.
Good.
I remember doing that in this evening before I got switched.
So what's the absolute value of -3?
3.
Also 3, right? Because if I go 1, 2, 3, I'm still 3 units away. It doesn't matter which way I went. The absolute value is still 3 units. The distance away from 0 is still 3 units. Let me show you a trick question now. What if I asked you for this? So absolute value bars work just like parentheses.
-4.
It would be -4. This chunk right here, the absolute value of -4 is 4, but now this is saying, hey, take the opposite of that. So my answer to that one would be -4. And let's just do one more where we do maybe just a quick evaluation. What if I did something like -3, absolute value of -3 plus the absolute value of 2? What would you get out from that?
5.
Correct. You do, they're just like parentheses. So I'd handle this one first. That's the absolute value of -3 is just 3. The absolute value of 2 is 2. 3 plus 2 is 5. I'm done.
Easy.
Okay.
Already solved.
Anybody have any questions?
Wait, we leave at 12:30, right?
12:35, I think. All right, let me give you your homework. I'm sure you guys will be able to finish this. I will open it up on Jupyter just a minute. Remind me, I never opened a blocks homework either. You're welcome. Okay, let me shut this down.